Okay, so this is question 1 from the 2025 Ordinary Level Maths Paper 2. So the table below shows the total monthly rainfall for Athenry for 2023. Each value is rounded to the nearest millimetre. The total rainfall in Athenry in June 2023 was 94. The total rainfall in Athenry for June 2024 was 72 millimetres. Find a percentage decrease in rainfall from June 23 to 24. Give your answer correct to one decimal place. So what we've really got to do here is take the bigger one, which is 94, subtract 72. That'll give you 22 millimeters in the difference. What we need is the percentage decrease. So you take the 22, you divide it by the 2023 value, which was 94 millimeters, multiply your answer by 100, and you get 23.4%. And that's really it. So question 2 in part A is work out the mean and the standard deviation of the total monthly rainfall for Athenry from the above table. Give both answers correct to the nearest whole number. Okay, so the way I did this one is just simply to put these values here, all of these values along here, into my calculator and let the calculator do the work. So I'm not going to go through that because it varies from calculator to calculator, but I got a mean of 133 millimeters and a standard deviation of 54 millimeters. So that's it for part A. Let's look at part B. The table below shows the same monthly rainfall values and is ranked from the lowest to the highest. So it says the upper quartile Q3 of the data is 183 millimeters. Find the value of the lower quartile and hence work out the interquartile range of the total rainfall for Athenry in 2023. So the way you do this is you count the number of pieces of data. You've got 12 numbers there. So we're looking for quartiles. So what you would do is you would take the 12, divide by 4, which gives you 3. 3 is a whole number. So what we do is we take the third and the fourth number. So we look at 1, 2, 3, 93 and 94. These two numbers here, and we have to get the mean of these two numbers, or the average of those two numbers. So we're going to add these two numbers and divide by 2. So it's Q1 here is going to be 93 plus 94. Then we got to divide by 2. So when you do that, you get a Q1 or a lower quartile of 93.5. So that's the lower quartile. So we want the interquartile range. I'll just write that in here, 93.5 millimeters. So we also want the interquartile range. Well, we're told the upper quartile is 183 millimeters. We subtract the lower quartile, which is 93.5. That gives us our interquartile range. And our interquartile range ends up being 89.5 millimeters. And that's it for question 1. Okay, let's look at question 2. There are two angles, A and 2A, in the right angle triangle as shown in the diagram below. Show that the size of the angle A is 30 degrees. Okay, so what we're going to do here is we're going to add up the three angles because the three angles added together give you 180 degrees. So we know that A plus 2A plus 90 degrees is going to give us 180 degrees. So A plus 2A is 3A. Plus 90 is equal to 180 degrees. Subtract 90 from both sides, so you get 3a is equal to 90 degrees. And then the 3 is multiplied by the a, so we're going to divide by 3 to give us 30 degrees. And that's really all you have to do for question 1. Question 2 then, the lengths of two sides are x and 10 centimeters as shown in the diagram above. Using a is equal to 30 degrees, find the value of x correct to 2 decimal places. So we have x out here, which is the opposite. This is 30 degrees here. We now work this out as 30 degrees. So this here is the opposite. This is the adjacent. So what I'm going to do is use tan of 30 degrees is equal to x over 10. So tan of 30 degrees is equal to x over 10. What you do then is the 10 is on the bottom of the fraction, it's dividing into the x, so you do the opposite to dividing, you multiply both sides by 10. So multiply the left hand side by 10, you get 10 tan 30 is equal to 10 times the right hand side. We'll just cancel that 10. You're just left with x. So at that stage, it's just calculator work. You just type in 10 tan 30 into your calculator, and you need to round to 2 decimal places. So what you get is 5.77, and that's centimeters. Okay, so that's part 2. Part B then, the triangle PQR is shown below. Some of the measurements are also shown. Work out the distance from P to R. Give your answer correct to 1 decimal place. Okay, so we want to work out this distance here. So what I'm going to do here is use the sine rule. So I'm going to work out the size of this angle here. Find the sine of this angle divided by this side is equal to the sine of 104 divided by 11. So the first thing we have to do is work out this angle here. So again, we just take 180 degrees, subtract 41 degrees, subtract 104 degrees, and that will give us the angle at Q. And you'll find that's 35 degrees. So this angle here is 35 degrees. So now we can use the sine rule. So I'm going to say the distance from P to R is divided by, I should say, the sine of 35 degrees is equal to the distance from P to Q, which is 11, divided by the sine of the opposite angle, which is 104 degrees. So this is what I've just got to solve here. So when you have a fraction equal to a fraction here, you can cross multiply. So I can say the distance from P to R times sine 104 degrees is equal to 11 times sine 35 degrees. And then finally, that sine 104 there is multiplied by the PR. So I can divide by sine 104. So I'll just get PR on the left-hand side. And then on the right-hand side, I've got 11 sine 35 degrees, which I've got to divide by sine 104 degrees. So we have to give this correct to 1 decimal place. So the distance from P to R then is going to be approximately equal to 6.5 centimeters. All this here is just calculator work. And that's it for question 2. Okay, next question then, question 3. The diagram below shows 3 circles labelled P, Q and R. Write each of the letters P, Q and R in the correct place in the table so that each circle matches its equation. So let's have a look at our equations. Well, the first one is x squared plus y squared is equal to 9. So an equation of a circle in this format means that the center must be 0, 0. So we have 2 circles here with center 0, 0. Now the radius of this circle here is given by this number here. This is actually the radius squared. So if we need to square root 9 to get the radius of this circle, which is 3. So this circle here, Q, has a radius of 1, 2, 3. So the first one is just Q. The last one I'll do as well because it's in the same format. It's x squared plus y squared is equal to 1. So the radius here is the square root of 1. The center is 0, 0. So the radius here is 1. So it must be P. So P is down here. So the other one then is just R. Well, we can see here that the center is plus 6. You change the sign and take this number. Plus 6 plus 2. Again, you change the sign and take this number here. So it's 6, 2. And you can see here that the center of this circle R is 6, 2. So this must be R here. Okay, so that's that one done. The circle C has a center 3, minus 4 and radius 7. Write down the equation of C. So the equation of a circle is x minus h to be squared, and h then is going to be this number here, which is 3, plus y minus k, this is k here, minus 4, so it's minus 4, which is plus 4 to be squared, is equal to the radius, which is 7 squared, so that's 49. That's all you have to do for that question. Okay, next one then. The circle K has center minus 1, 3, which is here. The point 27 is on the circle K, so that's the point here. Find the radius of the circle K. So all we've got to do is find the distance between the center and this point here. So we've got to use the distance formula. So the distance then is just going to be the square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. So our 2 points are -1, 3 and 2, 7. So I'm going to say this is x1, y1. I'm going to say this is x2, y2 here. Let's put those numbers in. So we have the square root of x2, which is 2, minus x1, which is -1. So minus minus is +1 to be squared, plus y2, which is 7, minus 3, which is y1 to be squared. So we just have to work these out then. 2 plus 1 is 3, and 3 squared, 9. 7 minus 3 is 4, 4 squared, 16. That's the square root of 25, which is just 5. And do we have any units here? We don't, so it's just 5. Okay, hence or otherwise write down the coordinates of 2 points that are on the circle K other than 2, 7. Give your answer in the form A, B. Okay, so what I'm going to do here is look at the center. I know that the radius is 5 units. So I'm going to look at this point directly above -1, 3, and I'm going to look at this point here directly below -1, 3. So a point directly above -1, 3 will have x coordinates of -1. It'll have the same x coordinates because you come out the x axis the same distance, -1. So I'm going to look at these 2 points here that are directly above and below the center. So I know that the x is -1 here, and I know here that the x is -1. What about the y? Well, we know now that the radius is 5, so we've come up along here 3 to get out to here. So now we need to go up another 5, so this point here must have a y coordinate of 8. Same here. If we take 3 here and we've gone up along here 3, if we come down 3 and go down another 2 to bring us to 5, that would be -2 down here. So this is -2. So the 2 points are -1, 8, -1, 8, and -1, -2. And that's all you have to do for that question. The next question, question 4. A is -5, 3, B is 2, 0 are 2 points on the coordinate plane as shown in the diagram. We also have a point C out here as well. Find the slope of the line AB. So slope is just y2 minus y1 over x2 minus x1. If we take the point A, it's -5, 3. If we take the point B, it's 2, 0. So I'm going to call this x1, y1. I'm going to call this one x2, y2. All you got to do is stick those into your formula. So it's 0 minus 3, that's y2 minus y1. And then 2 minus -5 or 2 plus 5. So the answer there is just -3 over 7. So that's the slope of this line. Okay, next one then is hence work out the equation of the line AB. So to find the equation of a line AB, you need a slope, so we have that. You also need a point on this line. Well, we have 2 points to choose from. I'm going to pick this one here, 2, 0. So the slope then, slope is -3 over 7, and a point is, 2, 0. So we need to use the formula y minus y1 is equal to m into x minus x1 to find the equation of a straight line. So this is x1, y1 here. So we got y minus y1, which is 0, is equal to m, which is -3 over 7, times x minus 2. So the first thing you would normally do with these is to try and get rid of that fraction. So in other words, we want to get rid of that 7. So I'm going to multiply both sides by 7. So I multiply the left-hand side by 7. I'll get 7 times y minus 0 is just 0. And then because I multiplied this here by 7, I'll just be left with the -3. The 7 will cancel, and I'll end up with x minus 2 here. So 7y is just 7y. multiply out the bracket, you get minus 3x, minus minus is plus, 2 3 6. Now we have to give the equation in this format here, so I'm going to bring everything over to the left hand side. So I'm going to take the minus 3x and add 3x to both sides, so it'll give me 3x on this side. I'll have the plus 7y. I'm also going to subtract 6 from both sides, so I'll have minus 6 on this side, and because I added 3x and subtracted 6, I'll end up with 0 on the right hand side. So that's my answer. This is the equation of that line. Okay, part 3. C43 is the third point on the coordinate plane. Work out the area of the triangle ABC, and they give us a hint here. The point C is plotted on the diagram on the previous page. So let's just have a look at that triangle. We're looking at this triangle here, so over to here and then down to B. So the area of a triangle is half the base times the height. So if we take this part here as being the base, what we can do is use that as the base, and then we can count this here as the height. This is height here. So we can see that the height is 3 units. And the base then will just be 1, 2, 3, 4, 5, 6, 7, 8, 9 units. So it's half of 9 times 3. So that's all we got to do to find the area of that triangle. So the area of a triangle is equal to half the base times the height. In our case, it's going to be half of the base we said was 9, and we said the height was 3 units. So when you do half of 3 times 9, you get 13.5, and we're looking at maybe units squared. We don't have actual units in this question. Okay, so that's it for that one. Let's have a look at the next one then, part B. The lines K and L have the following equations. Investigate if the lines L and K are parallel, perpendicular, or neither. Show working to support your answer. So the first one then, if we just have a look at line L. So line L has slope 2 over 3 because it's in the form y is equal to mx plus c. So you can just, all you have to do is really just read off the coefficient here. It's in the form y equals mx plus c. So 2/3 is the slope. Now the second one is in the form ax plus by plus c is equal to 0. So this is line K. So this is in the form ax plus by plus c is equal to 0. And the slope here is just going to be minus a over b. This is one way of doing it. I'll show you a second way in a minute. So all we've got to do is read off a, which is 2. So it's minus 2 over b, which is 3, the coefficient of the y. The other thing you can do is just rearrange this. So you can just put it in the same format as the first one. So what you can do is subtract 2x and add 7 to both sides. So you'll get 3y is equal to minus 2x plus 7. So all I've done there is I subtracted 2x from both sides and I've added 7 to both sides. You can see you've got a 3 attached to the y there. So it'd be minus 2 over 3x plus 7 over 3. So now that's in the form y is equal to mx plus c. And look, we got a slope of minus 2/3. And when we did it the minus a over b way, we also got a slope of minus 2/3. So let's see, they can't be parallel because minus 2/3 is not equal to 2/3. So that means they're not parallel. Let's see, minus 2/3 multiplied by 2/3 will give us, well, minus times plus is minus, top times top is 4, bottom times bottom is 9. That's not equal to minus 1. In other words, if you multiply two slopes together and you get minus 1, then the two lines are perpendicular. But when we multiply the two slopes, we don't get minus 1, we get minus 4 over 9. So therefore, they are not perpendicular. Now, therefore, they are neither. So therefore, neither is the answer. And that's it for this question. Okay, next question, question 5. J and K are two parallel lines as shown in the diagram below. The size of some of the angles are also shown. Find the size of the angles A, B, and C. So we can say that the size of the angle A anyway is equal to 60 degrees. It's vertically opposite. So A is 60 degrees. We can now work out B. So angle B is equal to 180 degrees minus 60 degrees minus 75 degrees. So if we work out angle B, we should get 45 degrees. So B is 45 degrees. So the way I'm going to work out C is to look at the fact that this line here is parallel to this line here. So that means this angle here must be 45 degrees because it's corresponding. So this angle here is 45 degrees. So that would just mean then that if we look at the big triangle here, we've got 75 degrees, we've got 40 degrees, and we've got 45 plus something will give us 180 degrees. So I can just make an equation there. I can say 180 degrees is equal to 40 degrees plus 75 degrees plus 45 degrees plus some angle C degrees. So all I got to do is subtract 40, 45 and 75 from 180. So it's 180 degrees minus 40 degrees minus 75 degrees minus 45 degrees. That will give me my angle C. So let's work that out then. So the size of the angle C then is 20 degrees. So that's 20 degrees there. So this is 20 degrees, B was 45 degrees, and A is 60 degrees. Okay, next question then. Let's see, we have B here. The diagram below shows the isosceles triangle ABC, where AB is equal to AC. So this is also 9 centimeters here. D is the midpoint of BC, so it's the midpoint, so that means this must be 5 centimeters here. AD is perpendicular to BC, and AB is equal to 9, we have that. BD is equal to 5, we have that. So you use the theorem of Pythagoras to work out the distance from A to D. That is, find the distance from A to D. Give your answer correct to 1 decimal place. So we're looking at this triangle here. We got to work out the distance from A to D. So this is a right angle triangle, so we can say 5 squared plus this squared is equal to 9 squared. So I'll write that out. So we're saying 5 squared plus the distance from A to D squared is equal to 9 squared. That just means then the distance from A to D squared is equal to, subtract 5 squared from both sides. That's 9 squared minus 5 squared. So that would just give us the distance from A to D then equal to square root the left hand side. Because we've got a square here, we square root the left hand side. We need to square root the right hand side as well. So it's the square root of 9 squared minus 5 squared. So when you do that, we just have to put that into our calculator. And it says give your answer correct to 1 decimal place. So that is 7.5 centimeters. And that's it, to 1 decimal place. Show that the triangles ABD and ACD, so this triangle here and this triangle here, are congruent. So we can use ASA, SSS, SAS, or RHS to prove that 2 triangles are congruent. So I'm going to use SSS. I'm going to say, well, 9 is equal to 9. That side there is equal to that side there. It's a common side. And I'm going to say 5 is equal to 5. So let's write all that out. So I'm going to say AB is equal to AC first. So I'm going to say the distance from AB is equal to the distance from A to C. Well, you must give a reason as well whenever you make one of these statements. So we are given this in the question. We can also then say that AD is equal to AD. So you can say the side AD is equal to the side AD. This is a common side. And then finally we can say that the 2 bottom parts here, these two, this edge here and this edge here, are both the same. We're given that in the question as well. So BD is equal to DC. So BD is equal to DC. Again, we're given that in the question. We're told that D is a midpoint. So therefore we can say that triangle, let's see, ABD is congruent to triangle ACD by SSS. And that's it for this question. Okay, next question, question 6. The marks in an exam were normally distributed as shown in the diagram below. The mean mark was 62 and the standard deviation was 14. Use the empirical rule to answer A1, A2 and A3. Use the mean and the standard deviation to fill in the missing numbers along the horizontal axis on the diagram below. Well, they tell us the mean is 62, so that must go here. They tell us then that the standard deviation is 14. That means you add 14 to 62. That'll give you 76, so that must be here. This is the first standard deviation above the mean. This is the second standard deviation above the mean. And the same on the left hand side as well, below the mean. 1 standard deviation below the mean, 2 standard deviation. So what we need to do now is subtract 14 from 62. That'll give you 48. Subtract another 14 from 62, or in other words, subtract 14 from 48. That will give you 34. So they're the numbers that go in there. Okay, so a student is chosen at random. Find the probability that this student has a mark between 34 and 90. So if we look at 34 and 90, we can see here that 34 is 2 standard deviations below the mean. This is 2 standard deviations below the mean. 90 is 2 standard deviations above the mean. So we know from the empirical rule that 95% of the data lie between 2 standard deviations above and below the mean. So the question is, find the probability that a student has a mark between 34 and 90. So the probability will be 95% or 0.95. Okay, 150 students sat the exam. Estimate the number of students who got marks between 48 and 76. So now if we look at 48 and 76, we're looking at 1 standard deviation below, 1 standard deviation above the mean. So we know that from our empirical rule, there are 68% of students between these two numbers here. 68% of the data lie between 1 and -1 standard deviations from the mean. So all we've got to do is get 68% of 150. So when you do that, you get 102 students. Okay, next one. Owen writes down 5 positive whole numbers from smallest to largest. For these 5 numbers, the median is 9, the mode is 6, the range is 11, and the mean is 10. Find the 5 numbers that Owen writes down. Now, because there are 5 numbers, that's an odd number of numbers, which means there is a median. The median exists. The median is part of the data. So they tell us the median is 9, so 9 must go there. Now, they tell us the mode then is 6. So 6 is lower than 9, so I'm going to put 6 here and 6 here. Now then they tell us that the range is 11, so the range is the maximum minus the minimum. So the minimum is 6, so all I need to do is add 11 to 6 to give us this number here. Then to find the one remaining number, then I'm going to use the mean. We know that the mean is what you get when you add up all the numbers and divide by the number of numbers. So in other words, 10 must equal 6 plus 6 plus 9 plus, we'll call it x for the moment, plus 17, and then divide that by their 5 numbers. So the first thing I'm going to do here to work out what that number is to multiply both sides by 5. So if I multiply the left-hand side by 5, I'll get 50. The 5 will cancel on the right hand side, and actually what I'll do as well is that I'll add up 6 plus 6 plus 9 plus 17. That'll give me 38 plus x. So all I've got to do now really is just subtract 38 from both sides, and that will give me 12. So this remaining number is 12. So that's it for this question. Okay, next question then is question 7. Sean is playing 2 tennis matches. He either wins or loses each match. The probability that he wins the first match is 0.6 and the probability that he wins the second match is 0.7. The outcome of the 2 matches are independent. Use this information above to complete the tree diagram below by first of all writing the probability associated with each branch of the tree diagram into the appropriate box, and secondly working out the probability for each outcome and writing it in the appropriate box in the final column. Okay, so let's work out these ones down here first. So if this is 0.6, this one here must be 0.4. These two must add up to 1 because there's only a win or a lose possibility. So these two here must add up to 1. So this here must be 0.4. The same out here. If this is 0.7, you can only win or lose. So if this is 0.7, this must be 0.3, 1 minus 0.7. So this is 0.3. Again, this must be 0.7, as this one down here is 0.3. Now to work out these values out here, what you've got to do is come up along this branch here and multiply 0.6 by 0.7. That gives you 0.42. So to work out this one here, you come up along this branch and then down along here. So it's 0.6 times 0.3, which will give us, let's see, 0.18. So this is 0.18. And then to work this one out here, you've got to come down along this branch and then up along this branch here. So you multiply 0.4 by 0.7, and that gives you 0.28. And that's everything filled out, I think. Yeah. So let's move on to the next one. Based on the tree diagram, what is the probability that Sean wins at least one match? So if we look at these probabilities here, we've got a win here and a win here, so we've got to include this number here. We've got a win here and a lose here, so we've got to include this one. In this case, he's won at least one, so we've got to include this one. If we come down here, he loses the first one, but he wins the second one, so we've got to include this one as well because he wins at least one. Down along here, he loses one and he loses one, so we don't include this branch here. So it's going to be 0.42 plus 0.18 plus 0.28. So the probability that he wins at least one is going to be 0.42 plus 0.18 plus 0.28, and that is 0.88. So that's your answer there. Okay, Sarah also plays tennis. Each time that Sarah plays a service game, the probability that she wins is 0.78. Assuming that winning each service game is independent, what is the probability that Sarah will lose her next service game? That is, that she won't win her next service game. Well, if the probability of winning is 0.78, then the probability of losing is equal to 1 minus 0.78, because she can only win or lose in this case. So it's going to be 1 minus 0.78, which is 0.22. What is the probability that the first service game that Sarah loses is her third service game? Give your answer correct to 3 decimal places. So in other words, she must win. So it's the probability of winning and then losing. So that's equal to the probability that she wins the first game is 0.78. And means you multiply. Winning the second one then is also 0.78. And means you multiply. Losing then is 0.22. So you just got to multiply those 3 together and you get a final probability of 0.134, and that's the 3 decimal places. A child's football is in the shape of a sphere and has diameter 18 centimeters. Find the volume of this ball. Okay, so the volume of a sphere is 4 over 3 pi r cubed. We've got to give our answer in terms of pi. So it's 4 over 3 times pi times the diameter is 18, so the radius must be half that, which is 9. We've got to cube that. So our answer there is in terms of pi. So in terms of pi, it's going to be 972 pi, and that's centimeters cubed. An adult's football is in the shape of a sphere and has volume 5424.6 centimeters cubed. Work out the radius. Give your answer correct to 1 decimal place. So again, the volume of a sphere is 4 over 3 pi r cubed. This time we have the volume. The volume is 5424.6. So put everything else in that we know. We know that, we know pi, and we got to work out the radius. Okay, so we just got to solve this for r. So the first thing you're going to do is multiply both sides by 3 because we have a 3 on the bottom of that fraction. So if you multiply 5424.6, multiply that by 3, you'll get 16273.8, and that's equal to 4 pi r cubed. So the next thing you can do here is divide both sides by 4 pi. The 4 is multiplied by the pi is multiplied by the r cubed. So if you divide both sides by 4 pi, you'll just end up with r cubed on the right hand side, and then on the left hand side you'll end up with 1295.027856. So what you've got to do now is get the cubed root of both sides. So you just got to get the cubed root to get rid of that 3 there. So we want this to 1 decimal place, so get the cubed root of the left hand side and you'll get 10.9. This is a radius, so it's in centimeters. Okay, part D then. The expected goals is a method used to measure the probability that a particular type of shot will result in a goal. During a game, a team has 15 shots on goal. The statistician gave each shot a probability of resulting in a goal as shown in the table below. Use the information in the table to work out the expected goals of the team in this game. That is the expected value of the number of goals that would be scored. So this is an expected value kind of question. So you got to write down the expected value. The way you do this is you take the probability, multiply it by the number of shots, the outcome, and if you like, the number of shots in this case. So it's going to be 0.1, which is 10%, multiplied by 6, plus 0.2, which is 20%, multiplied by 5, plus 0.4, which is 40%, multiplied by 3, plus 0.7, which is 70%, multiplied by 1. So you do each of those. So 0.1 times 6 is just 0.6. 0.2 times 5 is 1. 0.4 times 3 is 1.2. And 0.7 times 1 is just 0.7. Add those and you'll get an expected value of 3.5 goals. And that's it for question 7. Okay, next question. Question 8. The table below shows the number of new private cars sold in 2023 to the nearest 100, broken down by fuel type. It also shows the percentage of these cars that were of each fuel type corrected 2 decimal places, and the size of the angle that would represent each fuel type in a pie chart. So the first question is to complete the table above by working out the 2 missing percentages for diesel and hybrid, and the size of the 2 missing angles for diesel and fully electric. Give each percentage to 2 decimal places and the size of each angle correct to the nearest degree. Okay, so we'll do the percentages first. I'm going to do this one here first. So we know that there were this number of new cars. There were this number in total. So all we got to do is work out this number as a percentage of this number here. So you put this number over this number and multiply by 100. So let's do that. So it's 25900. So it's 25900. You got to divide by 117400, multiply by 100. That gives us, let's see, 22.06, 22.06%, and that's the 2 decimal places. So that number goes in here, 22.06%. So we'll do the same with this one here. So it's 3300. So let's do that, 3300 over 117400 multiplied by 100. If you do that, you get 25.81, 25.81%. So that goes in here. So next thing we've got to do is work out these angles. So what we've got to do here, really, the way they work these out is there are 360 degrees in a full circle. So we need 22.06% of that and put our answer in here. Same here, get 19.17% of 360 degrees, put our answer in here. Let me just work out those two. So the first one is 22.06%, 22.06% of, or multiplied by 360 degrees. If you do that, you should get 79 degrees. If you get 19.17% of 360 degrees, you should get 69 degrees. And again, that's to the nearest degree. So we've got 79 and 69. So 79 degrees there and 69 degrees here. So have I got that right? 22.0679 and 69, yes. Okay, so next one then. Use the information from the table on the previous page to complete the pie chart for diesel, fully electric and hybrid. Label each sector clearly with the fuel type. Okay, so I'm going to have to do this freehand. You guys will need to use a protractor and a ruler, and you will need to put in the number of degrees and the label here. So let's do the first one. What have we got to do? Diesel first. So let's have a look at diesel up here. So if we look at diesel, we need to draw an angle of 79 degrees. So if you were to do that, 79 degrees is, let's say, somewhere around here. Now you guys would need to, as I say, use a ruler there, put in the angle 79 degrees, and then what was this one? This one was for diesel. So write in diesel here as well. So the next one we have to do is fully electric. So fully electric, we can see we need to draw an angle of 69 degrees. So you would draw an angle of 69 degrees, which would be, let's say, somewhere around there. 69 degrees, and this is fully electric. And the next one then is, what was it? Fully electric and hybrid was the next one. So hybrid is 93 degrees. So this here should be 90 to 93 degrees. And this was hybrid. So we had 1, 2, 3, 4 types, and we've got 1, 2, 3, 4 types there. So that's it. That's your pie chart. Okay, next one then. The scatter plot below shows the fuel efficiency of 10 popular petrol cars and their engine types. So we can see here we've got engine size along here, and we've got fuel efficiency up along here. So we can see that as the engine size gets bigger, the fuel efficiency gets lower and lower. So let's see, there is a correlation between engine size and fuel efficiency. Based on the diagram above, pick a description from the list below that best describes the correlation between engine size and efficiency. Explain your choice in relation to fuel efficiency and engine size. So first of all, I would say it's a negative correlation because it's sloping that way. If it was sloping that way, it would be a positive correlation. Now it's quite strong, I think. So it's strong negative. In other words, you can draw a line down through here and most of the points will be fairly close to that line. Let's see the explanation then. Okay, so the explanation can be something like there is a downward trend, hence negative correlation. And you could also say it is strong since most of the points are close to the line of best fit, or a best fit line if you like. And then we would need to say something like as engine size increases, fuel efficiency decreases. Okay, next question then. Tom says the correlation coefficient between two sets of data is 5. Explain why this cannot be correct. Okay, so the correlation coefficient is from -1 to 1. 5 is outside this range. Okay, next question then. A random sample of 815 cars was picked from new cars in 2024. Show that for this sample, the margin of error for a population proportion is 3.5% correct to 1 decimal place. So the margin of error is 1 over the square root of n. So that in this case is just 1 over the square root of 815, which is 0.035, but as a percentage it's 3.5%. If you like, that times 100 would give the percentage. So it's 3.5%. 106 of the 815 new cars bought in 2024 were electric cars. Work out the percentage of new cars in this sample that were electric cars. Give your answer correct to the nearest percent. So to find one number as a percentage of another number, you take that number, make it into a fraction first, put it over the other number, 815, and then multiply by 100. So that is, to the nearest percent, it's 13%. In 2023, 19.2% of all new cars were electric. So a reporter claimed that the proportion of new cars being bought in 2024 was different to 2023. Use your answers to part C1 and 2 to test the claim that the percentage of new cars being bought in 2024 is different from that in 2023 at a 5% level of significance. Show your relevant calculations, state your conclusion, and give a reason for your conclusion. Okay, so we've got to do the calculations first. So the calculations would be that the population proportion is somewhere between, so it's going to be the proportion of cars bought in 2024, which was 13%, and then we got to subtract the margin of error, which was 3.5%, and then these are percentages here. And then we got to take the 13% and add the 3.5%. So when you do that, the population proportion for 2024 should be somewhere between 9.5% and 16.5%. So that would be our confidence interval for the proportion for 2024. Now the conclusion is, if we take the null hypothesis as being that the population proportion is 19.2%, and the alternative hypothesis then is that the population proportion is not 19.2%. The conclusion then is that we would reject the null hypothesis and conclude that the percentage of new electric cars being bought in 2020-24 is different from that in 2023. The reason for that is because in 2023 we had 19.2% of all new cars bought were electric, but that percentage is outside the confidence interval for the population proportion of cars bought in 2024. So 19.2% is outside the confidence interval at a 5% level of significance. Okay, and that is it for this question. Okay, next question. Question 9. Claude is making a wooden table for her woodwork class. The triangle ABC below is a scale diagram of the tabletop. The tabletop is supported by one leg attached to the centroid as shown in the diagram on the right. On the diagram below, construct the midpoint of the side AB, label this point D. If using measurements and calculations, show all your calculations. So we've got to do a midpoint for side AB. So the way you would do this is you would put your compass here and draw an arc. So the arc would look maybe something like this, and then you would take your compass, put it here without moving the compass in or out, draw another arc on the other side. So that would look something like that. Now I have that well off center, but you would then connect up those 2 points, and this would be your midpoint. Now this is clearly not the midpoint. I'm doing this freehand, so the midpoint would be maybe somewhere around here. And that's really it for the first part of this question, I think. Just construct a midpoint of the side AB, label the point D. So assuming you ended up with a line down along here and your arcs, this here would be the point D. It says hence construct a centroid. So the way you would construct a centroid is to connect up this midpoint here to the opposite side. So you would draw what's called a median down here like this. Then you would turn the page around and do the same with another side. So what you would do is maybe from the side AC, you again would put your compass here, draw an arc here, draw an arc out here, and then from C the same thing, draw another arc here, draw another arc here, and connect these two up. And this would be your midpoint here. Now again, let me just take those out of it. You would leave them there, by the way. Don't rub out your arcs or your construction lines, and you would end up with another line there like that. What you would do then is connect up the opposite vertex, so B, to that point there. This here then would be your centroid. So this is your centroid here. And that's really the center of gravity of that triangle. Okay, so that's it for that question. Let's have a look at the next one. Finn is making a pair of tables. These are triangular tables, one bigger than the other. The bigger tabletop is an enlargement of the smaller tabletop. The scale factor for the enlargement is K. The longest side of the bigger tabletop is 45. The longest side of the smaller tabletop is 36. Work out the scale factor or prove that it's 1.25. So you would take the longer the image length, which is 45, divided by the object length, which is 36, and you do get 1.25. So that is K. The shortest side of the smaller tabletop is 25.5 centimeters. Work out the length of the shortest side of the bigger tabletop, correct to 1 decimal place. So the shortest side of the smaller tabletop is 25.5. We know the scale factor is 1.25. Multiply those together and you will get 31.9, and that's in centimeters. The area of the bigger tabletop is 724 square centimeters. Use K is equal to 1.25 to find the area of the smaller tabletop. Give your answer correct to the nearest centimeter. What you've got to remember here is that the image area divided by the object area is actually K squared. So when you take the bigger tabletop as being 724, the scale factor is 1.25. You've got to divide that by 1.25 squared, by K squared, to work out the area of the smaller tabletop. So when you do that, you get 463, and this is in centimeters squared. And again, this is to the nearest centimeter squared. Okay, a table used for a cookery demonstration is in the shape of a sector of a circle with a radius of 160 centimeters. The table has a teacher section, so the teacher section is here, and a demonstration section which is here, and a work section which is around here. So this shaded area is the work section. It has a width of 40 centimeters. Work out the area of the work section. Give your answer correct to the nearest square centimeter. So what I'm going to do here is I'm going to find the area of these two sectors here. There's a white sector here, and then there is the white sector and the grey sector together, if you like. So the large sector, I'm going to subtract the two areas, and that'll give me the area of the shaded region. So I'm going to take the area of the sector, the large sector. The area of a circle is pi r squared, so it's going to be pi times the radius, in this case is 160, which we've got to square. That would be the area of the complete circle. I don't want the complete circle, I want a fraction of that. So what fraction do I need? I need 250, that's the angle, over 360. That's the fraction of the entire circle that I need. So that'll give me the area of the entire sector there. So what I want now is to subtract the area of the smaller sector, which is this area here. So that should give me the area of the shaded region. So again, that's going to be pi r squared. In this case, the radius is 120 because this is 40 from here to here. Subtract that from 160, that'll give you 120 centimeters here. So it's 120 squared. And then we don't want the entire circle, we want a fraction of it, which is 250 over 360. So that's the area of the shaded region then, the work area. So let's see if we can work that out. If you work out this part here, you'll get 160,000 over 9 times pi. If you work out this part here, you'll get 10000 pi. So all you've got to do is subtract those, and you'll get 24435, and that's square centimeters because it's an area, and this is to the nearest square centimeter. Okay, let's look at the next one then. Each participant attending the demonstration needs at least 60 centimeters along the outer circumference of the work section of the table to carry out food preparation. Find the maximum number of participants who can attend the demonstration. So what I'm going to do is I'm going to find the distance from here all the way around to here. And the way I'm going to do that is I'm going to find the circumference of a circle, which is 2 pi r, and then I'm going to multiply that by the fraction that we're talking about. Again, it's the angle 250 divided by 360. So 2 pi r, the radius in this case it's a large sector, so the radius was 160 centimeters. And I want to multiply that by the fraction we're talking about of the entire circle, which is 250 over 360. That'll give me the entire circumference of the work section that I just pointed out there a second ago. It'll give me that blue, this part here, from here all the way around to here. Now, it says in the question that each person needs 60 centimeters. So what I've got to do is divide this by 60 to see how many people will actually be able to work on the work section, on the workstation. So let's work all of this out then. If you work out this bit here, you should get 2000 over 9 pi. We've got to divide that by 60. So that's multiplied by pi there. So again, if you do that, again, it's just calculator work, you should get 11.6 people. But of course, you can't have 11.6 people. So the answer would be just 11 people. That's it for this question. Okay, so let's look at the next question. Question 10. Eva is a member of a sea swimming club. The club has 6 markers in the water labeled A, B, C, D, E, and F as shown in the diagram below. A, B, C, D, E, and F is a 6-sided shape where AF is parallel to CD. So AF is parallel to CD and AF is perpendicular to AC. So this is a right angle here and a right angle here. AB is equal to CD is equal to EF is equal to FA is equal to 200. They're unmarked. BC is equal to DE is equal to 150. Those two are marked as well. Eva swims from A to B, C to D, D to E, E to F, and back to A again. Find the total distance. Oh dear. Okay, so this is just a case of adding. So look, you've got to take 200, add 150, add 200, add 150, add 200, and add 200. So when you do all of that, you get 1100, and meters are the units. Okay, so that's number 1, very easy start. Let's have a look at part 2. The size of the angle ABC is 110 degrees. Work out the area correct to the nearest square meter of the triangle ABC, that is the area of the shaded region in the diagram above. So we've got to find the area of this triangle here. So we can see that we've got this side, and we have the enclosed angle. So that means we can use the formula half AB sine C. A is 150, B is 200, and C, the angle C, is going to be 110. So let's do that. So the area is equal to half AB sine C. In our case, we've got a half times 150 times 200, and then we've got to get the sine of the angle between those two sides, which is 110 degrees. So look, all of that is just calculator work. We have to give our answer to the nearest meter. So that's 14095 meters squared. Okay, so the third one then, Eva swims straight from A to C. Use the cosine rule to work out the distance from A to C. Give your answer correct to the nearest meter. Okay, so they're telling us what to do here. So we've got to find this distance here from A to C. So again, we have two sides in the enclosed angle, and we need to find the opposite side to the angle. So we can use the cosine rule. So let's just write that out. So it's going to be the distance from A to C, which we got to square, and then it's equal to the two sides squared, so it's 200 squared plus 150 squared, minus twice the two sides multiplied, so it's 200 times 150, and then we got to get the cosine of the angle between those, which was 110 degrees. So you just got to work through all of that. I mean, if you do these two first, you'll get 62500. And then if you do these ones, you'll get minus 6 0.0000 60,000, and then we've got the cos of 110 as well. Okay, so AC squared, when you do all of this on the right hand side, you will get 83021.2086. We've got to get the square root of both sides to get rid of that 2 up here. So when you get the square root of the right hand side and round it to the nearest meter, so it's going to be 288 meters. Okay, number 4 then. Hence or otherwise, work out the total area of the water enclosed by the 6 markers. So if we look here, what we've got is we've got a rectangle here anyway, and we have 2 triangles, and these 2 triangles are actually the same area because we've got 150 and 200. We've got 150 and 200, and this distance here is the same. We've just worked that out as 288 meters. So I'm going to find, well, we've already found actually the area of this triangle here. So all we've got to do is double that. That'll give us the 2 triangle areas. Then add those to the area of the rectangle in the middle, which is just 200 times 288. So let's do all of that. So the area of the triangle, so the total area, the area of the triangle was 14095. And we've got to double that because there are 2 of them. And then we're going to add the area of the rectangle in the middle. So that's just 200 multiplied by 288. And that's really it. When you do all of that, again, it's all just calculator work. So it's 85790, and that is in meters squared. Okay, so next one. Point A is the nearest point to the shore and is the start and end point for all swims. Ava wants to see how many routes she could swim starting at A by swimming to each of the 5 markers B, C, D, E, F once and only once, and finishing at A. So she could do from A to E, then over to C, then to F, then to D, and then back to A again. So that's one such route she could do. So we have to do another one. So what I'm going to say is from A to C to E to B, F, D, and A. So she can start at A, go to C, go to E, then she can go to B, then she can go to F, then she can go up to D, and then down to A again. Okay, so that's that one. How many such routes are possible is the next thing. So if we look at this kind of thing here, I'm just going to draw some boxes here. So I've drawn 7 boxes here. We're going to multiply the numbers in these boxes here. Now she must start at A, so that means there's only one possibility here, and that's A. At the end, she must finish at A, so there's only one possibility out at the end, and that's A as well. So in between then, how many possibilities has she got here? Well, if she starts at A, there are 5 other markers, so she has 5 choices there. Once she's picked one of those markers, she has only 4 left to choose from. And once she's picked one of those, she has only 3 left here to choose from. Once she's picked those 3, then she has only 2 left and 1 left here. So if you multiply all of those, you will get 120 routes. That's it. Okay, next one then. On a particular day, Ava wants to start at A, swim to 2 markers other than A, and then return to A. For example, she could do A, E, B, and A. Work out how many of these routes are possible. Well, again, if we do 4 boxes here, multiply our numbers. So she has to start at A and finish at A. So she only has one possibility there, A. At the end, she has to finish at A, so there's only one possibility there. So after she leaves A, she has 5 other choices for her second marker. And then once she's picked that one marker, she has 4 markers left to choose from there. So really there are 20 routes that she can choose. Okay, and that is it for this question and this paper.